So let's start today's session. My name is Balraj, and I'm here to present today's topic about product quality with CI/CD pipeline. Now, let me start by introducing myself. So, as you can see in this slide, that my name is Balraj, and I'm a senior software developer for almost more than 12 years now. Most of my recent career have been in iOS development, but from time to time I have been doing a full stack development also. So I have a background with the full stack development, as well as I have worked in different kinds of companies from startup to like a big tech companies. At present, I am working for Meta, correct, for almost 2 years now. So in that particular experience, what I've seen is that in recent times, CI/CD pipeline has been quite important. And not only big companies, but startups have also started investing in CI/CD pipeline. For what reasons is something which I'm going to share in this presentation. So what my aim in today's presentation is to basically share about what is CI/CD pipeline, what are the different steps that are involved in a general CI/CD pipeline. So I'm not going to talk about a particular tool. Neither I'm going to tell you, which tool is better. So this is more of a concept overview about CI/CD pipeline. How does CI/CD pipeline helps you to improve overall product quality, and how does it help you to move faster from a development cycle? So let's start by straight away diving into other things. So what I'm going to tell initially is about each step. What does we do at each step of CI/CD pipeline, and what you should expect at each step. And the next, what I would be telling you about is that which are the tools that you can use at every step. So this would give you a very holistic view of what a CI/CD pipeline is, and you can take this knowledge and basically try to choose whichever tool you want to, because now you have that basic fundamental understanding of the CI/CD pipeline and how does it basically, how you should basically build up your CI/CD pipeline to get the best outcome from there. So let's start. The first step that you have over here is the source. And what do you mean by the source? The source is the source code that you're working in. So the engineers would basically be developing feature in their local branch, and they will be committing their feature in that local branch. So this is quite early on in the stage where engineers would be building certain features, committing their code into their local branch, building again, committing it again, testing it in the local branch. So the thing that engineers would basically do is do the local dev testing as they move forward. Maybe write a couple of unit tests, try to run those unit tests. If you're doing a TDD kind of development where you are writing test first and then basically developing features to pass those tests. The next step that we have over here is the build. Now, this step would basically talk about when the engineers have finished their feature development and they want to raise a pull request. It's not just that they have finished the feature request development. It could be that they have completed a part of the code that they want to merge onto the master branch. Now, what happens over here is when they raise a pull request, if you have a CI/CD pipeline set up, you could run some test over here. You can run some signals over here, which could be static code analyzer or something like that, which would give engineers a signal that how well the code is. Moving to the next part, we have the test environment. Once the pull request is merged into the master, basically it shouldn't actually go to the production directly, but there should be a test environment which should run all the integration tests that you have. Tests that requires a lot more time to run would be the best place to actually run those tests. And depending on what frequency you want, obviously you don't want it to run every hour because that's going to consume a lot of resources. You can do that if you have so many resources, but yeah, we'll talk about that in depth. The next step is the canary environment. This is an optional step. It depends a lot on the kind of product that you have. If you think your product is large enough that you really want to test the product before it actually goes full fledged into production, so what happens over here is you do a kind of a small percentage of rollout. That's like 5% or 10% of the rollout uh, in the production, and you wait for the signals to come back. These signals could come back through different means. You could have some kind of metrics or logging mechanism which basically keeps on indicating that how well your code is or how well your feature is performing in those 10% of the users. Correct. Now, as I said, this step is optional. The reason why I'm saying so is that for a startup, correct, adding extra step in a CI/CD pipeline would only mean that they are delaying their product feature to go out on time, correct, and it may not add so much of value for a startup or a small scale product. But for a large companies or mid-sized companies where the impact is quite high, if a certain you know um, defect goes out into production, for those kind of companies it makes a lot more meaning to basically release it to a smaller section of their users and try to understand what signals that they are getting. This becomes really critical in key features. Okay. Now comes the last step, which is production environment. In the production environment, obviously, your feature, your product, whatever you have, is being available to 100% of the users. Now, what does that mean? That would mean that any issues that gets leaked out to production is really hard to basically, it has the most effect from a customer point of view, from a cost point of view to the company. Plus, it's the most difficult to fix also. So until and unless your every feature that you release is behind a kind of a feature flag or something like that, it's going to be really difficult to pull that back, and it becomes really even more difficult in case of if you are doing this with the app development. In case of web, it's still fine because you can push it again and everyone starts to get the updated thing. But for an app development point of view, it becomes really difficult because you fix that thing, you create a new app version, you upload that app version to Apple Store or Google Store, correct, and it takes certain amount of time to release it to the market. But still, you will also have those versions with a smaller section of the users which has that bug, so you can never pull whatever goes out in production from an app. Like, it takes a really long time, and the effects are quite big. So now, seeing all this step, what can we understand from this? We can understand that the cost of the bug is the most on the right side of this chart, and it becomes really important to also understand that the faster feedback loop which an engineer can get is on the leftmost part. So what does this mean is that I have touched a little bit about the bug cost. um, like I was talking about it, that on production the bug cost is quite high. And when we talk about faster feedback loop, that means when the engineers are basically, let's say, on the step of source, when the engineers are actually building their app on the local machine in their local branch, then what would happen is that they will be able to get the fastest feedback loop. If there are issues, they can fix it there and then before even committing to the master. So what do we need to do? We need to basically balance out between what are the feedback or signals we want to get at each step, because every step has its cost. For example, if you think that it's really great if you can catch all the issues on the source code or on the build step, correct, that would mean that you want to run every signal on these two steps. You want to run all your integration unit tests on these two steps, correct. But that would actually mean that you are increasing the build time, you are increasing the pull request build time, you are increasing the local development build time over there, and that would affect a lot on developers productivity. Hence you are again losing the cost, like it's a cost to the company if you lose developers time. So you cannot run everything on the source code, you cannot run everything on build, correct? But there has to be a balance between that. For example, like I'll explain which tools we should be running at every step in the next slide. Now, keeping in mind that the faster feedback loop is on the left side, and it's the least bug cost. Like if you catch a bug on the source, it's great. Like company has the least amount of cost, correct? But you also have to optimize developer experience. You can't let developers time be wasted, correct? So what two things you can do on the source code? You can actually run static code analyzer, for example, Sonar, correct? That's one of the examples. And what does static code analyzer do for you? It will basically gives you hint around best practices, anything related to code, correct? So if you have to put, you have to basically enable certain rules to understand. For different languages there are different rules to understand what are the best practices where you can make, simple mistakes, like memory leaks and all that. So all that you can detect through static code analyzer, and it will help you to catch these smaller bugs so that they do not get leaked out into production. Unit test, you can also run unit test. You can make things easier. For example, when the engineers are basically doing their build, you may not want to run at that particular point of time, but you obviously say, tell engineers that this is a simple script that you can always run before creating your pull request with the unit test. Like you can always start writing unit tests, you can always run those unit tests and see that your unit tests are passing for the feature that you are developing or the code that you are writing before you actually create pull request. Strict data types, obviously you can, one of the good practices is to have strict data types. What does strict data types would help you to do? It would basically help you to, you know restrict the domain, like the input domain that you have. For example, if your data types are not strict, correct, what you have to basically then do is you have to handle a lot of conditions with if else conditions within your code, and if you miss any of those conditions, it's hard luck. That issue would basically come up in production or somewhere down the line in one of those steps ahead. As well as documentation, you should enforce on, like, it's a good practice to keep documenting your code because it helps to understand uh, things better, for not just for you. Obviously documentation is not for the person who is actually writing it, it's for the person who is actually using your, like maintaining your code or building on top of your code or using your code to build something else, correct? So these simple practices at the source level or at the local branch level thing would actually help you to catch a lot of issues at the very first step itself. Moving to the next step, which is the build step, as we have talked about, that the build step is when engineers raises pull request. So they raise the pull request onto the master branch, and what things can you do? Obviously, again, you can automate running Sonar Cube, the static code analyzer. And why I say so is because at times engineer forget to run static code analyzer at the time when they are actually writing code or building the code. So this is another place where you can actually put it. You can automate this in your GitHub, and it will give a clear signal saying that, hey, you have missed something out. So this is something that you need to fix. And as a code reviewer, you can enforce that you should be fixing all your static code analyzer signals. Enforce PR to have test. That's another thing. So in a PR, you can add certain rules saying that a PR which do not have any test added to it should have a test added to it. Correct. No PR can be merged without a test. These are good practices that you can enforce. That would again help you to catch issues earlier on. Again, you can have in this is quite optional, a readme file. Like, I do find it to be useful, but as an engineer, I know how hard it is to document the code. So yeah. But anyways, I generally like to do this, adding readme file wherever it's possible, because it helps not just the person who is writing the code to have a clear thought of mind, clear thought of line, but also for the person who is actually reviewing. So it becomes really helpful for the reviewer also, and for anyone who comes after that to use that piece of code. Unit test. Unit tests are also quite important. As I said, tests are important. You should write test, but during the build phase, what you can run, which would not actually affect on the performance of the PR when it's building and running all those tests. There are two kinds of tests that you can run. One is the unit test, other is the snapshot test, because these are the fastest tests to run, as well as it takes a lot less time. So your actual time to build and run all of these tests on the PR would be limited, as well as you can gain maximum most benefit out of it. So I generally prefer to run both of them. Unit test, automate that part onto the PR. Code review, obviously. This is another important part where we should try to enforce code review with at least two reviewer, if possible. If you are like, you do not have the leverage of having two reviewers, one is at least bare minimum. So code review is quite important. And I have already done a video back about talking about what is code review, what are the benefits of code review, correct? How you should do a code review. But to summarize, code review is not meant to find, point out issues or things lagging in your code, but it is to make, first is, it helps you to understand whether the code that you have written is something which other engineers can understand, and if they can understand, can they find some basic mm, kind of issues in your code, correct? If they can help you out to find those issues in this step, you are actually finding a bug that could lead to a bigger issue in production, correct? Hence, it's again quite important for the business point of view that you find issues as early on as possible. So yeah, code review becomes an important step at this point. Moving to the next part, the test environment. Now, the test environment is an important step where you run all the long running test. Most of it is end to end test or integration test. So now all the end to end test and integration test runs on this step. Hence, it could make things little slower over here. My recommendation is to run the test environment probably every night, or maybe let's say once in couple of days, because it consumes a lot of resources. So you need to run it on a regular frequency, but that frequency needs to be fine tuned based on the resources that you have within the company. So I would always prefer that you run integration test and end to end test on this thing. Now, one key thing that you can do over here is, for example, if your product is globalized, it's across different domains, it's across different boundaries of the world. For example, it's in EU, US, Australia, or somewhere else, correct? What you can do is you can parallelize um, these tests. You can parallelize the tests that you are running in US. You can parallelize the tests that you are running in EU, and you can deploy them in the test environment in parallel, as well as run them in parallel, correct? So that helps you to basically improve the um, it helps you to basically improve the time within which you actually complete the entire thing. Imagine that you have a product which has spanned across the world, and you are running you're deploying them one at a time, running the test one at a time. It becomes really, a lot slower. So parallelizing this across the world boundaries would actually help you to run things faster. Coming to the next step, which is the canary environment, this is a quite an interesting place. Now, when you have actually deployed, so as I said before, canary environment is an optional step. It helps you if your product is actually big, quite big, correct? And if you, or else it may not be big, but if you think that your changes, any production issue has a lot more cost to bear than, you know, like finding it earlier, correct? It could be a very critical domain, for example, where an issue which goes out could actually cause company to lose a lot of money. So what you can do actually do is deploy it to the smaller section of the user, as I said, could be 10% of the users, correct? And you can use signals. Now over here I have tried to explain few signals. For example, you can build up a dashboard of product reliability, where you see all these signals, all the loggings that you have done in your product, correct? Capturing those data points and trying to calculate product reliability, how well your product is performing within those 10% of the users that you have. You may also have a like you have a crash system which gets monitored. So crash monitoring is also important. Now, if you see a spike within those 10% of the user for a crash, you get to know, and you have still have the time to pull it back. It hasn't affected the remaining 90% of the users. Performance monitoring, again, quite important. Maybe your product has a performance issue with the feature or the code changes that you have made. You can create alarms, that means signals for the above metrics. Now, this is more of an automation thing. Like monitoring could be manual and monitoring can be automated. Correct. As a starter, in order to basically, not to overburden everyone within the team, it's always better to start with a manual monitoring, see how well the product is performing, because it also gives you a signal that, where you should draw the line in terms of the product quality should not fall below that particular number. For example, in case of product reliability, let's say you have a product feature where you do not want the reliability to fall below, let's say, 95%, correct? Now in that case, you can put up an alarm over there, an automated system which would get triggered when the reliability numbers fall below 95%, and it actually informs you. This is quite a complicated process and it requires a lot of fine tuning. The reason for that is you have to filter out the noises that's there in the data, and becomes really tricky at times. It may so happen that there is a trend change or there is a holiday, and you find your product is not being used by a lot of people, but it but for the alarms it may not make sense, correct? Because numbers have dropped, the usage number have dropped, and it may again trigger the alarm saying that something has happened, but it could only be a change in trend because of a holiday. But so you have to basically keep on evolving your alarm system. Talking about progressive deployment, lowest to highest users, correct? So that's again kind of a deployment strategy that you can have, where you can say that I'm deploying in a area of the world where there are least number of users, and then keep on progressively deploying to the highest number of users area. Why would this help? This would help you to basically, catch or get those signals wherever it's possible, as early as possible. Right? And it gives you a lot more time to understand what's going wrong, because with the least number of users, obviously the impact would be the least. Correct. And you should always have a rollback strategy. Now that's what I said, that you can have feature flags built into you, like added into your code. That's another practice that you can have. It's really important. Once you have you start to deploy, correct, you should have a rollback strategy. And if I remember this correctly, in mobile apps, in both the platforms, iOS and Android, the marketplace itself provides you a kind of a progressive rollout strategy, where if you find issues, you can stop the rollout of your app, the specific app version. Obviously you cannot roll it back, but then you can actually stop that over there, and you say, okay, fine, this is the build, I don't want um, to release it to 100% of the user. You can stop it over there, fix the issue that you have, and obviously roll the new fixed version out again to everyone that you want, so that entire thing goes out again. The last step that we have over here is the production environment. Obviously, it's going to be very similar to the canary environment. It's just that it's going to be on a much bigger scale. It's 100% of the user that you have. So again, you should have all your metrics, all your visibility on the product reliability, crash monitoring, performance, alarms, and rollback strategy. The rollback strategy over here in production becomes a little tricky thing to do, because in case of www, it's maybe is simpler to do, but in case of app, it becomes almost impossible until and unless you don't have that, a feature flag inbuilt into your code where you can dynamically change the behavior of the app. That's the reason why I would say many companies are quite interested in doing server driven development. These are kind of new terminologies that are coming up. So server driven development, people want to do that a lot more, because it helps them to build a rollback strategy in mobile apps. Correct. So yeah, so we have talked about all of these things, how and what things that we can do on every step, how you can add different tools, different kinds of strategies, different metrics, loggings in every step to get proper signals. And yeah, I believe these are the things that would help you to build a good CI/CD pipeline. These are just the fundamentals of building a CI/CD pipeline, and this would really help you to improve your product quality, release your product faster, be confident in the quality itself of the product. Correct. So this is what I had or have about talking about CI/CD pipeline today. This is a very general introduction. So yeah, we are moving to the Q&A thing. Any questions that anyone has? Feel free to write it in the chat. I'll be happy to answer. If not, then yeah, feel free to connect to me um, on LinkedIn. Ask anything that you want to ask on LinkedIn. Yeah, great. Since I do not see any comments or any chat messages, I assume that yeah, no one has any issues, questions also. So thank you everyone. Thank you everyone for your time, and I hope this is helpful for everyone. Yeah, this is my LinkedIn, so feel free to reach out to me on this thing. So yeah, thank you everyone, and see you next time. Thank you.